Welcome, everybody. Good morning or good afternoon, wherever you are. I'm Angela Schottenhammer, one of the coordinators of the Pacific People Forest Project, together with my colleague PI Maria Cruz Berrocal and colleague Marta Dominguez del Mas. And it is my great pleasure to have for our first training event today Patricia Murrieta. She is Distinguished Professor at Tec de Monterrey for Digital Humanities and Artificial Intelligence and holds a chair in Digital Humanities at Lancaster University, where she has also carried out lots of interesting and intriguing projects. And I would say that she is maybe the specialist for Spanish-speaking digital humanities and AI, and it's really a great pleasure to have you here, Patricia, today, especially for this first training event. So I give you the word, and we are all very, very curious.
Great, Angela. Thank you very much. Well, first of all, thank you very much for the invitation and particularly for the opportunity to show you the research and innovations that we are carrying out with my research group. I will say that more than a training session, I will rather give you a presentation or an introduction to the work that we have been carrying out for the past few years. And I want to showcase basically the things that we do in the group. So later on, when we do more what I will call proper training, where I actually teach you something else, and we have hands-on, actually experience with the tools and the things that we have developed. So I would like to first, do this introduction, and then I think later on we will have opportunities within the group to actually, do that hands-on experience with historical documents, thinking about not only data, but also objects, people, and so on, right? So you might already know that I'm an historical archaeologist from Mexico, but I'm also a specialist in computer science. And I have particularly specialized in the transdisciplinary exploration, not only of theories, but also in the creation of methods and techniques and artificial intelligence software to answer basically questions in the fields both of history, but also archaeology. And today I would like to show you how this research is not only revolutionizing these fields in the humanities, but is also leading us to address what I will say, or at least in my opinion, some of the most interesting challenges in the use of historical information within computer science. Okay, so I'm sure that many of you, even if you don't want it because it's all over the news, you have been following quite close the development of artificial intelligence. And you will probably agree with me that today what we call the new oil or the new gold is what we call real data. And if you look at the most powerful technology industries of the present, like Meta or Google or OpenAI and so on, they are basically pursuing our data. So data that is basically generating by humans, right? Now, why they are pursuing what we call real data, so this is to say data generated by humans, and why so valuable, I mean, beyond the traditional uses such as marketing and so on, it is basically because in the last 9 years, real data is what has made what we call the generative AI revolution possible, right? And it is because it is from this data that large language models can be basically trained. And regularly, I will ask you here whether you know basically how tools like ChatGPT are basically trained, and you might know, you might not, but for those that are not entirely clear about it, basically large language models emerge from a field that we work in computer science that is called natural language processing. So we shorten that to NLP, right? And in this field, what we do is basically to teach machines how written or spoken language basically works. And this started in a very simple way with the autocomplete function in phone text or browse searches, where through basically statistical analysis, it is tried to determine what is the most probable word that will follow another, right? So, for example, when you type into Google search, dogs are better than, and the browser suggests cats or humans and so on, right? What this function is basically doing, it is based on an enormous sample of writing, and it is basically searching for what will be a statistically most probable word to follow from another, right? And this begins many years ago, around the 1990s. And then we can fast forward to 2017. And in a quite iconic moment, one of the Google's research group created an architecture called transformers, which basically enable the development of a model that instead of taking basically just some sentences and their surrounding context, it basically allowed companies such as OpenAI to download real data that exists on the internet and train a model at a scale that had never been done before, right? So this now resulted in what we call today ChatGPT, Gemini, Cloud, and so on, right? Now, at the beginning of last year, the technology industry began to sound the alarm because the growth of these models basically depend on the data with which they are fed, right? This is to say real data. And individuals like this one, like Elon Musk, basically declared last year that all the real data that could be used to train large language models have been already exhausted. And although there is what we also call, in parallel to real data, synthetic data, that is data created from already trained models, these present a series of very important problems for large language models. So according to a think tank that is called Gartner Analytics, in a 2023 report, they basically said that by 2024, up to 60% of the data used in artificial intelligence will be synthetic rather than real. And this basically raises multiple challenges, but also dangers. And I will just leave you with two that are quite simple, but important ones in here. The first one is that artificial intelligence that feeds on itself basically replicates inherent biases, right? And the second is that it is actually very difficult to evaluate or to separate results coming from mixed data sets using already trained models. Now, I'm sure you are then asking yourselves, what does this have to do with digital humanities, right, or historical archaeology? Well, something that the great technocrats do not know, because, of course, their views is tied to the idea that only Western and modern knowledge counts, is that in our historical and colonial archives, for example, those of Mexico, the General Archive of the Nation in Mexico, we have 5 centuries of real data in millions of historical documents, right? Now, one of the problems of this is that accessing this data is not as simple as basically carrying out what is called optical character recognition, as it is done with modern data, right? And I don't know if you have heard about optical character recognition. I'm sure you have used it many times. So this is basically the technology that allows us to transform text in an image into a computer readable text, right? So when you have, for instance, a PDF, which is technically an image, and copy paste that text from the PDF, what the software is basically doing is recognizing through a model, you know, this is a letter S, this is an A, this is a C, and so on, right? So that image basically becomes machine readable text. But in the case of historical documents, at least well until the 19th century, as you know, most documents are basically handwritten text, right? So transforming these documents into machine-readable text basically presents enormous complications that typed text do not present, right? So just to begin with, there is, first of all, tremendous variability in the types of handwriting used. And you probably know as well that becoming an expert in paleography bibliography normally requires extensive not only training, but years of a specialized training in itself, right? And there are also challenges as important as they are interesting, such as the fact that language obviously changes over time. And in the case of Mexico, these documents may be a combination of Spanish with Latin, for instance, but also with one or several of the 68 indigenous languages that we have in this country, right? So we have addressed this problem precisely with artificial intelligence. How? Well, we decided to begin tackling this directly with a project that ended a few years ago called Unlocking the Colonial Archive. And in here, we did a first attempt precisely to do handwritten text recognition of historical text. And then with the project that I lead now called the Fleets of New Spain, we have now achieved very important results with it. And I will share this in a moment. And these results include the fact that we use a technique related to optical character recognition called handwritten text recognition. This is to say, the automated recognition of handwritten texts with artificial intelligence. And so just in other words, what I mean by that is that we took the 5 most frequent types of handwriting in New Spain and created basically models which now are allowing us to produce transcriptions automatically. But how do you know that what the machine is basically producing is actually correct, right? So we do a measure of how accurate a transcription is through a metric that is called CER. So this is character error rate. And these are in here, you can basically see the results of our models. I'm missing in here another model that I will tell you about it at the end of the presentation if you are interested, but these are the final results that we have with these models. So when I tell you that our italic cursive, for instance, handwriting model has an 8.7 character error rate, what that basically means is that when we ask our model to automatically transcribe a document that is written in italic script, out of 100 characters, 8.7 may be wrong, right? And so in this case, basically, you can see that the transcriptions produced by our models are now below 10% character error rates. And this means that in the coming years, we will be able to automatically transcribe millions of historical documents from across Latin America. And we are already beginning to do this with 35,000 documents from the Fleets of New Spain corpus. I can tell you a bit more as well about the corpus and so on later on. And all of this sounds really fantastic, right? And to a certain point, I think it really is. However, the challenge that we still face is that HTR, or handwritten text recognition outputs, while they are remarkable, they still can contain errors, right? So we are talking about, we achieve a 10% character error rate, so a few characters might be wrong, but this depends on many different things. And this error might range from character confusions to spacing problems, unresolved abbreviations, for instance, among many other things, right? So as I was saying before, our models achieve between 5 and 9% character error rates, depending on the script. And this is all good, but we still face a challenge for large-scale computational analysis, particularly because to do things with what we call natural language processing tools, which are basically trained with modern language, becomes very difficult because, as you know, in early modern Spanish, there is no standard punctuation, and these tools basically rely on that to carry out tasks and analysis, right? So if we want basically to do extraction of massive amounts of information from historical documents with natural language processing techniques, we need standardized Spanish, right? And we have a series of problems in there. So we also have the problem that even with a very low character error rate, we really want to stick to the rigor that the archaeologist or the historian might want, right? So this is to say that character error rate might not be, a low character error rate might not be enough, right? So we also want historically accurate documents, right? And beyond that, even when the transcription is perfect, I will say that we face another challenge, and that is that some historians, but also the public, might struggle with early modern orthography, right? So we have outdated verb forms and inconsistent punctuation that the general public might not be familiar with. And so we are doing all this not only to carry out the research that we want as historical archaeologists, but we also want to democratize basically information, right? So in Mexico, we work with different indigenous communities and with different populations as well. And so we also want to give access basically to the information to many different types of communities that might not be a specialist in paleography, right? So this is also a challenge. So in a parallel project now funded by Schmidt Sciences, we started this basically this January. We decided to create a solution to this problem in a two-stage pipeline using what we call fine-tuned large language model, specifically designed for historical Spanish. And in this particular case, we are basically working with our corpus of the fleets of New Spain with over 35,000 handwritten documents from the 16th to the 18th centuries. And these are basically administrative records, geographic surveys, and legal texts from the National Archive of the Nation in Mexico, but also from El Archivo General de Indias in Spain. And these documents basically, as I showed you before, are written in early modern Spanish with multiple calligraphic styles. And they have been, we are basically working in the transcription using handwritten text recognition. So to further transform these digitized records into usable machine-ready format, we have basically built a two specialized pipeline model that work in sequence and that we are basically building at the moment. So this is to say, once we have the handwritten text recognition results, we might still have, a bunch of different problems within, as I was saying, spaces, things that are missing, character confusions, and so on. So the first thing that we basically wanted to do was to create a first stage, which is, after that, to clean even more these documents. And what we are aiming to do here is basically to train, and we are already in that process, to create a large language model that is called Historical Clean Spanish. And we basically start with it by applying deterministic heuristic rules. So this is to say a simple pattern recognition matching for consistent errors like character substitutions and safe abbreviation expansions, right? Then the idea from there is to feed the output into a fine-tuned machine learning model, which is a character level sequence to sequence transformer. And then from that, we will be training this model with around 500,000 words of ground truth transcription, spanning basically in 4 calligraphic styles: itálica cursiva, procesal simple, redonda, and procesal encadenada. And the idea, as I was saying before, is that this model learns to correct the remaining HTR errors that the heuristics basically miss, such as really complex abbreviations, for instance, what is called context-depending spacing, and subtle character confusions like cedilla for C and things like that, right? And so the output should be a clean but also paleographically accurate early modern Spanish text. Now, we are looking into a second stage here as well, and we started not the training yet, but already the establishment of the model, which will be a second model called Historical to Modern Spanish Model. And this is a standardization model. So this model basically will take the clean, already early modern text and then modernizes it into contemporary Spanish. And we are basically fine-tuning another small llama model with over over 50,000 manually created sentence pairs, basically, guided also by a series of philological rules. So we are working with philologists on this. So we don't want basically to do brutal standardizations to Spanish, right? We basically want some soft standardizations that basically allow us then to work with other natural language processing tools, right? So these rules, for instance, cover orthographic changes, like, as I was saying before, cedilla to se, X to J, and so on, grammatical updates, modern punctuation conventions, and lexical standardizations, right? And the model, learns basically when to apply these rules and critically when to preserve historically significant terms, right? So, and the result that we are hoping for is to achieve not only accessible, but also modern Spanish that is suitable basically for computational text analysis and language processing tasks like name entity recognition. This is to say the recognition, for instance, of things like people's names, place names, institutions, dates, and so on, right? And we are also aiming to release that for broader public engagement. Now, what makes this work quite exciting for me is that we are not only just building generic transcription tools, we are basically creating what we call domain-specific models trained on the linguistic reality of colonial Mexican Spanish, informed by expert historical knowledge at every stage, right? And our team of historians, basically what we do is to manually annotate the training data, validate model outputs, and basically we ensure the semantic fidelity of it. And our computer scientist team basically handle model architecture, training pipelines, and evaluation. And this is what we call an expert in the loop approach. And this basically means that our models are at every single stage involving human input, so they preserve the historical nuance while enabling computational scalability, right? So we are hoping to see measurable improvements in the not too distant future. So just to tell you about the stages in which we are at the moment. So we started this kind of like side project in January. We need to finish it in July, so we are around at half of it. We are starting now to put together a series of technological developments in order to develop the second model. And then we are aiming for our cleaning models to achieve a character error rate below 3%. And for our modernization process, we are aiming to do a 70 Blue score, again, human references, and significantly improve then downstream natural language processing performance. But the real impact for me is what this will enable, right? So researchers will be able to computationally analyze centuries of colonial governance, indigenous Spanish interactions, economic networks, and of course, geographical knowledge at a scale that was previously impossible. And we are making these documents as well accessible, not just to specialists, but to students, teachers, and as I was saying, the public alike as well. And we are also committed to open science, right? So all our code, models, databases will be publicly released with full documentation, and other teams basically working both in historical texts in Spanish, Portuguese, or similar Romance languages will be able also to adapt our methods. So we are creating basically pipelines that we aim to be reproducible, right? So in short, what we are doing is to use the latest advances in large language models to bridge 3 centuries, not to replace historical expertise, but actually to amplify it, and to open colonial archives to computational inquiry while preserving, obviously, their linguistic and cultural integrity. Now, as I was saying before, you may ask why this is important. So just to give you an idea, the Archivo General de la Nación de México has 58 linear kilometers of historical documents. Let me repeat that because it always blows my mind when I say this. These are 58 linear kilometers of documents. These are millions and millions of pages covering 5 centuries from Mesoamerican to colonial and independent history. In the case of Mexico, to which only a small drop of that ocean has been accessed because only a small part of it has been transcribed, right? And in these documents, as you know, are not only the grand narratives of the formation of the country, but also local histories, the knowledge of many cultures, and the knowledge as well of 68 indigenous languages. Now, what are the consequences of this development? First, to me, we are provoking a profound change in how we see history. By having access to thousands of sources that were previously unavailable, an entire world of knowledge possibilities basically are opening up, right? So on the humanities side, in terms of impact, we are creating what we call unprecedented access to our country's historical information so that anyone can access it. And in the technological side, we are unlocking an entire mine of data, which give us the possibility not only to contribute substantially to the technological development of large language models, but also of having a more meaningful representation within them. And this is to say that, do you know that what proportion of data is representing Latin America basically exists in models like ChatGPT-5? Well, it is basically estimated that this is less than 0.2%, right? So this basically means that when you or your students, for instance, ask ChatGPT a question, the generated answer will be deeply biased, as it is still essentially representative of a very particular view and data of the global north. And we have not stopped there. As a key step, we are now taking together with UNAM in Mexico is to create handwritten text recognition models also for indigenous languages, such as classical Nahuatl, which, as you may know, it was the lingua franca of Mesoamerica for quite a long time, still very relevant today. And this responds to one of the major problems that we see today, and this is that digital tools are designed and based on Western languages, leaving not only many others outside, but also the ways that many other cultures, besides, you know, well, Europe and, you know, the global north basically thinks are, you know, excluding all these ways of thinking. And so one specific line of research that we work on is precisely the colonial technologies. And I can tell you more about that. And large part of our effort and our work focuses precisely on the creation of inclusive technology. So, well, okay, so we have already solved one of the greatest challenges, which was how to release information from millions of historical documents. Now, once we have that, what we do with it, right? So within the Fleets of New Spain project, we are developing also artificial intelligence-based software and techniques that are allowing us not only to identify and extract, but also to analyze these thousands of documents in ways that were not possible previously, right? And as you know, in addition to being a digital humanist, I was telling you before, I am an archaeologist, and in my career, I think one of the great questions that has led me to study the early colonial period in particularly is that in the 16th century, the beginning of modernity basically takes place with the encounter between America and Europe. And in one way or another, this is the opening of everything, of the systems that we are living in today, right? And this painting makes reference to the fleets of New Spain, which were the fleets of ships that you already know were organized by the Spanish Empire. And they can literally be thought as the first globalizing enterprise, not only because of the economic dynamics within their organization, but also because absolutely everything that was transported between both continents had basically to pass through these ships. So that is all the people traveling between Spain and Americas, the animals moving between continents, the oranges arriving to Mexico, the tomatoes taken to Europe, all the plants, knowledge, gold, mineral products, spices, enslaved people, absolutely everything exchanged between the two continents basically passes through the fleets in general, right? And in this case, we are talking about particularly the fleets of New Spain. And the Spanish Empire, being the bureaucratic apparatus that it was, right, it recorded everything that was transported through an institution that you probably know well in the project, obviously, that we are talking about, called La Casa de la Contratación, where basically millions of documents about these processes were preserved, and which today is the archive of the Indies in Seville, right? Now, in this project, we are carrying out 5 case studies, and I will briefly mention just 2 of them in here. And in the first one, we will attempt to trace how indigenous medical knowledge from the America was recorded and extracted. So we know that indigenous physicians possessed enormous knowledge about medical plants and extraordinary practices that Europe, for instance, did not have, right? And the Spanish began to record this knowledge and take it to Europe, and much of it later will contribute to the medical revolutions in the 17th and 18th centuries, right? And this knowledge and these plants travel through these fleets, and this information is contained basically within these thousands of records. And another important case that we are going to be carrying out is about indigenous slavery. So as you may know, very early in the 16th century, debates began in which friars like de las Casas, for instance, argued that indigenous people should not be enslaved like Africans because they had souls and so on. And this led to an early royal order prohibiting indigenous slavery in the Spanish Empire, right? And on the paper, this appears very progressive, but in reality, we know that the practice basically persisted, and it simply became invisible due to this prohibition, and also due to all sorts of, historical processes. But current research basically suggests that indigenous slavery may have reached a magnitude greater than that of the transatlantic African slave trade, right? And it is also in these thousands of fleets documents that we can trace through many different means these practices and the people who participated in or were victims precisely of these networks. Now, how are we doing that? Okay, so my research group created a method called geographical text analysis. And with this, we have also created a software that allows the identification and extraction of information at the scale from historical documents while simultaneously identifying related geographic information. So this method and the software that we created basically allows you to ask questions such as, what places are mentioned in this collection? But more importantly, you can ask what is being said about a particular topic of interest and whether it is connected to a specific geography. So to give you an idea of how this, or what this does, we use a combination of machine learning techniques, including natural language processing techniques and corpus linguistic methods, together with geographic information science techniques. And so basically what we have developed is a geographically oriented big data exploration approach that allows the computer to identify, link, and analyze information in enormous corpora that otherwise will take us a lifetime to explore. And so to better understand how we do that, in natural language processing, we basically use machine learning to teach the computer how to identify keywords and concepts of interest in very large historical collections, right? So for this purpose, we are finishing to develop another piece of software called Histotag, which we can basically annotate these documents at the scale and then train artificial intelligence models so that the machine can do this annotation automatically, right? So in this case, for example, I'm showing you an example from the geographic reports of New Spain, the Relaciones Geográficas del siglo XVI, de la Nueva España. And in here, what you are basically seeing is that we have these categories on the left. So food, social groups, institution, dates, health, measurements, plans, information about different types of animals, ethnic groups, locations, and so on. And so what we did with that was we created basically an ontology. And with this, we taught the model how to identify things such as data about, as I was saying, food, health, and so on, right? So we created complete analytical pipelines with that. So what we can do from that, this is just a screenshot from the software. In the next part of the training that I will give you later on in time, this is to say not today, but as the project basically evolves, you are going to be using precisely this software, and I will do a demonstration of that when the time comes. But having, for example, a gazetteer with geographical information and the annotated corpus, basically the geographical text analysis software allows you to identify all instances that speak about a particular topic and whether that information is linked to a geography, right? And we can also export this into other formats, such as JSON files or CSV files, for use, for instance, in Excel, and to conduct then advanced spatial analysis in other software, such as geographic information systems, R, and so on, right? So in this case, what you are seeing is basically the extraction of information related to health, in particularly, and what you see in here is what we call the keyword in context. This is to say the extraction of all these terms and entities that are related basically to health and diseases, and the context in the text to the left and to the right. We also have metadata in here that allow us to go back to the text. Actually, in the software, when you click, for instance, in these cells, what the software does is to update of the different information in the windows. So it basically takes you to the place that is talking about in geographic terms, and then also to the place that is talking about basically in the context. And we can also do all sorts of different types of analysis with this, right? So in the extraction of information, it will tell you where in the document this particular keyword in context is located. So again, when you click on it, it takes you back to the actual text, and then it also extracts information about the latitude and longitude, about the place name that is probably related to that keyword in context, and then it gives you as well the reference to the bibliography basically that talks about that specific place. Now, what this means, in effect, is that we now have a very powerful way, not only to identify relevant information in thousands of records, but also of mapping and investigating the geographies associated with any topic of interest, right? And think also that this works basically with any corpus and combination of collections, right? So in our specific case, the geographic data, we took it from a first project that I carried out a few years ago called Digging into Early Colonial Mexico, where we dedicated quite a lot of research to basically identify all the place names from the geographic reports of New Spain, the 16th century geographic reports of New Spain. And we identify around 15,000 place names, and we created basically a GIS data set and the first digital 16th century gazetteer basically of New Spain. And you can actually download it from our GitHub repository and so on, right? And as I was saying, think that this works with any kind of corpus. So it works with the Relaciones Geográficas, but it works basically with any kind of corpus that you might want. And so if I want to search across thousands of millions of pages of information, not only about the relaciones geográficas, but also the corpus of fleets of New Spain, all at the same time, I can actually do so, right? And it can be also applied in other contexts as well. At the moment, for instance, we are working in quite interesting proposals on looking at how this kind of technology can be basically used, for instance, in police work. So we have been speaking with the Constabulary of Lancashire in the United Kingdom, because they are quite interested in analyzing patterns of crime, for instance, from the reports that they basically produce that are basically type reports, right? And this can be equally useful, for instance, in the context of national health services. So it's a method that basically works with any kind of text as well. Now, what we have achieved with this, just to give you a quick example, we haven't published this yet. We are still working on it. But in here, what you are basically looking at is at all the mentions, for instance, that are related to the epidemics that happened during the 16th century in the geographic reports of New Spain, right? So what we have achieved in here is a visualization, but also the localization of how the different people that participate in the geographic reports of New Spain are basically speaking about diseases, and particularly those related most likely with widespread epidemics, right? And these developments basically are not ending here. From these different proposals and methods, we are now generating as well an artificial intelligence laboratory based here in Tecnológico de Monterrey, where all these tools and methods are basically coming together, right? So imagine then that in the future, you hold an archive or a collection, or large institutions, for instance, such as archives, libraries, and museums, want to transform their own collections into what we call collections as data. This is to say, collections that you can use not only in the most traditional ways as we do in historical archaeology, or you as a historian, but actually that can go through computational processes. And you can use this laboratory to move basically from a simple digitized output. So this is to say a digitized document with apparently little obvious value to collections as data, as I was saying before, and to go basically into the part of the analysis that everyone basically would like to explore, right? And we are basically starting also to look into the idea of how we can create this also as a startup to look into all these pipelines. Okay, anyway, I'm conscious of the time, and I think I have given you already quite a lot of information, so I'm going to stop here, but I'm very looking forward to your questions, and I will be, of course, very happy to tell you more about it. So thank you very much. Muchas gracias. Tlazocamati.
Thank you.
Thank you very much.
Patricia.
Excellent.
Should I stop sharing the screen?
Okay.
Yeah.
If anyone has any question, now is the time. Please raise your hands. Edwin?
Estamos aplastados, sí. We are really overwhelmed by everything you said. Yeah, it's
No worries, that's okay. I mean, take your time. I know that is a lot of information, and don't worry if you don't get what I'm talking about. I just ask me about it, and I will try to explain, with more care as well, what I mean by natural language processing, what are the techniques that we are using, and so on. No problem whatsoever.
Marta?
I think Marta? Yeah. I cannot hear you. No te escucho, Marta. I think it's because you are muted.
there are two hands, but yeah, we can't hear anything. Yeah, that's true.
A ver, habla ahora, Marta.
No, no. Can you hear me? No, eh?
Yes.
Yes, yes.
Now we can.
Yeah. Oh, yeah? Ah,
Yep.
yes. Yeah, Patricia, what a fantastic presentation. I mean, it is indeed overwhelming. I think that you guys have developed like the Rosette Stone of AI, you know, I mean, of historical documents. No? So for us to be able to dig now and to retrieve information efficiently. And so I wanted to know, yeah, basically what you are doing also, what you say that you can do, one of your projects is to find out some plant names and then see the uses that they were having, no? So this is something that would be ideal for our project, right? If we could find out, I mean, it's a combination actually with a project with the GIS, with the historical GIS, because it would be great if we could find out in Spanish documents also expeditions that went to the Marianas, and then what plants they describe, what uses they may describe. Do you think that this could be possible, that we could implement your technology in Spanish archives?
Yeah, absolutely, Marta. I mean, this is something that we have discussed several times, for instance, with Maria and with Angela as well. I think let me share my screen again and let me show you how this looks like, right? So it's much better basically to show it rather than to just explain it, right? But can you see it now? I'm just sharing basically the geographical text analysis software. And what you're seeing here is a combination. I mean, these tools are basically a combination of, I don't know if you have worked in digital humanities before, you are probably familiar with Boyan tools, right? And this is a corpus linguistic tools that basically allows you to do this kind of extraction of information from any kind of text, right? So in here, what we have is the documents reader. So what I'm showing you here is on the right side is the historical gazetteer that we developed, right? And then on the left side, what we have is a tab with documents. So these are all the geographic relations of New Spain, the geographic reports, sorry, of New Spain. So you can exchange through that and you can basically read them, right? And the things that you see here in little colors are basically the different entities that we identify, right? So in the case, for instance, of plants, we might be able just to click in there, and I will do it in a second. But something else that I want to show you is that we develop these entities. In reality, it's not an ontology, it's a control vocabulary. But, you know, if you want to go into the actually technical bits of that, we can talk about it. But what we basically wanted to do was to give natural language processing, name entity recognition and machine learning models, a way to identify entities with different tags, right? So you have, for instance, information about health, and those categories might be a bit more complex, right? So it's not only about health, it's illness and remedies. You might want to, you know, just look at measurements. We might want to look at animals and the types of animals. We might even want to look at locations, for instance, and you might want, you know, to look at civil jurisdictions and so on, right? So what I'm going to do next is just basically to ask the software to extract all the information that is contained about plants in the geographic reports of New Spain, right? So what it's basically doing in here is retrieving all those instances, in this case, 6,239 different entities that talk about plants, right? And when I actually click on it,
Patricia, when you talk about entities, are you talking about documents, physical documents, or what is the output that you get? So all those entries that you get.
Yeah, sure. So the entity is basically the description of something, right? So we call entities, for instance, food, social group, institutions, plants, and so on, right? But what is basically retrieving is, and I'm going to show it here, is the instance of one mention in one, for instance, document, right? So in here, if you see, I'm going to click in árbol, for instance, and it's taking me in the document, in the Relación of Minas de Zumpango, it's taking me to that instance where this is mentioned, and it's also taking me geographically to the place that is related to. Does that make sense?
That's fantastic, yeah.
Right,
Yeah.
and so we can actually do that, you know, with the whole corpus. I can, you know, ask where is this type of algodón basically mentioned. It takes us there, and it's also giving us the references and a bunch of different pieces of metadata information that we can then extract, right? So you can do that kind of search, but you can also do searches basically by keywords with Booleans. So you can say, right, so I want to search for this and not that, or this and that, or this like that, and so on, right? And we are also developing another query builder in here, which is basically allowing us to do a bit more complex searches with something that is called SQL. Don't worry about it, you know, it's terminology that it doesn't matter that much. It just allows you to do more complex things, right? And if you want as well to not search in this way, but to search, let's say, for instance, what is being said about Francisco de Montejo directamente, you can basically double click on it, and then it will basically do exactly the same search and extract all the information that has this entity related to Francisco de Montejo. Or let's say that you don't want to do that. Let's say that you don't want to, whoops, I click on something that I shouldn't, but let's say that you don't want to look basically through entities, but just let's say this key chain of words, right? Instrucción de su majestad. So I'm just basically highlighting it, and it's going to do exactly the same search. Or let's say that you don't know at all what you are searching for, but you are interested in the geographies, and you want to know what is being said about this geography. So we can actually do that search also geographically through this tool in the geographies, right? So it's going to tell you, you know, everything that is, you know, mentioned in that particular corpus. So regarding plants, Marta, yes, of course. I mean, we can do that. At some point, we agreed with Maria that in the research stage that you are going to be doing with us, we are precisely going to be working on these things, how to create your own corpuses, corpora, sorry, how to annotate them, and so on. Yeah.
Fantastic. Thank you so much. I mean, this has so many possibilities. It's really fantastic. Thank you.
Thank you, Marta.
Jorge, it's your turn.
Yes, can you hear me?
Yeah.
Ah, perfect. I was worried about that. Yeah, I introduce myself. I'm a historian. Now my project is about historical demography. So what kind of archive I'll be interested in is parochial archives. So I have a project to actually use this technology about automatic transcriptions to mine a little bit all those books, all those parochial books to do demography, to make to analyze demographic trends. So my question is, I would be interested actually how we can use your model you are creating to transcribe those. First of all, if it be suited for this kind of archives, and I'll be very interested to see if this model can translate automatically those kind of archives. Yes. Thank you.
Yeah, sure, Jorge. So let me tell you a bit more about handwritten text recognition in that context. I was going to ask you, where are your archives from?
Well, they're open source as well in the British Library. So they use a triple, yes.
Sorry, I meant what geographies are they from? So is this the Americas? Is this Latin America? Is this a specific country, or are you?
This is a very interesting question that is in Latin America, in Peru.
Ah, okay,
And
great. Yeah.
as
Yeah.
you know, like is the church actually that produce
Got
them.
it.
And
Yeah, got it. Yeah, the
and I
reason
was
why I was asking her. Oh, sorry, go on.
mhm.
Yeah, finish. That's all.
I was asking if you know, because I know that priests they move quite a lot in Latin America. So I'd be interested if this kind of writing, if one person, for example, he started in Mexico and then moved to Peru, will be able to trace this person in time, you know. As you mentioned that you have like some, I think I saw the technology, what's it called? CATMA or Open Refine to track the different words used in different countries. I'd be interested actually to see if we can track the persons as well as the plants and localization. It'll be interesting to see what kind of collaboration you have there with other countries as well, you know, like Peru or other countries, Colombia. So maybe something to do as well in this sense, you know. Thank you.
Yeah, that's great, Jorge. Yeah, the reason why I ask is because we are noticing something that is quite interesting and is not that studied. And this is that the types of calligraphies, right? The types of traditions of scribes, it has been always assumed, right, that Spanish is Spanish and that, you know, that at the end of the day, the calligraphic styles might be exactly the same. And we studied, you know, paleography manuals from Spain and so on, right? But one of the things that we are noticing now with quite a lot of this work is that it is not necessarily the case that in the viceroyalty, for instance, of New Spain, and I will argue that might be the same with the viceroyalty of Peru, although it is Spanish, right? And although there are sort of the same calligraphic styles, there might be slight variants. And why this is important for handwritten text recognition is because we have in the experience, but also in the literature, is very well identified that you have to train, or the better results or the best results that we have with handwritten text recognition is to train a model per calligraphic style, right? And so if you have a very strong variation within one type of calligraphy, which you normally do, but even more, that might change slightly results, right? So what I mean by that is that we train these models, particularly with data from the Spanish archive, so from documents from the General Archive of the Indies, but also with documents from here, from the Viceroyalty of New Spain, right? Particularly from Mexico. So we are now making some experiments with colleagues in Paraguay, for instance, to actually see whether our models actually perform equally okay with theirs. So far, so good. You know, I can tell you, yes, they work, is not a problem. I think we are not going to have any kind of problem with that. But I will just caution to say, let's try different documents from different places and so on to see how that works. Because, you know, this is the first time that this is done, so we don't really know, right? Whether our models will perform perfectly well everywhere, right? So we'll generalize perfectly fine in every single case. But what I can tell you is that for the majority and for the kind of things that we have done, I mean the tests that we have done with other documents, they actually work. We are actually looking forward to have a look at the corpus of Pacific Peoples Forest as well, and to see, you know, how that works with our models too. Now, regarding the actual access to the models, yes, we will be available. We haven't released them yet because we are still doing all this pipeline that I was telling you before, right? So we have already the handwritten text recognition models. They would be able basically, so if you need them for your specific research, we are normally happy to give you access. It's not a problem for us as such. And at some point, we will obviously release them as well. But the reason why we haven't done so yet is because we are still in this process of the pipeline that I show you that has been funded now by Schmidt Sciences, where we are basically aiming to create a full pipeline where you go from handwritten text recognition, then you input the output of handwritten text recognition into a further model that actually cleans it much better, and then it standardizes it to a certain extent in order for you to do natural language processing, which would be the thing that you will want in order to identify the people that you want to trace around, the plants that you want to trace around. For that, basically what you need is what we call name entity recognition, right? So what you do is basically to teach the computer what a place name is, what a toponym, what a people name, what a person name is, right? And all these different entities that I was showing you before, and then the computer will identify them for you automatically, right? But as with any computational process, I will say it's very important to have what we call very good quality ground truth data. So this is to say that we need to create basically very good data ourselves. So it's important for us first to identify these entities, these categories ourselves, so we can teach actually the machine how those things look like before, you know, just giving it to ChatGPT and so on to just extract information, because we have done that. We have done quite a lot of experiments with large language models, and they are rubbish with our documents because of so many different reasons, right? So
sorry to interrupt you, Patricia. Sorry. Yes, because which kind of archive did you take into account in your model? Was it was it parochial, institutional? Or...
No, they are basically the Relaciones Geográficas de Nueva España, which are basically the geographic reports of New Spain. So these are governmental, let's say, reports. Then we also have listas de pasajeros. We have all the archive of the fleets of New Spain as well, which basically relates to the information that was created by the Casa de la Contratación. And then we also are experimenting with many other types of documents, which are relatos, for instance, de tierras, which basically belong to indigenous communities here in Mexico. So we have a variety, right, of things, but we are basically focusing on governmental data, right? So we haven't taken, for instance, parochial archives, but they should work, you know, basically the same. It shouldn't be a difference in that sense, because the technologies apply to any kind of text, as long as the text is clean, right? Yeah.
Yeah, and my question, why I asking that, because the layout, you know, is quite different in parochial books. You have like you have the name of the person on the left, and then a sentence which starts with this baby born from I don't know, Pedro, the father is Pedro, etc. But you have this kind of organization which is quite specific for those archives. And I don't know which technology are you using. Is it Pilaya you are using
Pilaya
right now, or Kraken? Okay.
Pilaya.
So basically they don't analyze the layout is line by line, is it?
No, you need a layout model, you know, to do that kind of record. So it's the same with censuses, for instance, and with tables and so on. You will need a layout model before you apply any handwritten text recognition model. But at the end of the day, the HTR should work exactly the same once you have precisely the layout. Now, one thing that is important about this part of the layout and thinking about how do you scale this into millions of documents, right? So this has been one of the questions that it has been in my mind for a very long time, right? So how you go from a research project like the ones that that we have worked on, to actually give this to the Archivo General de la Nación, right? How do you scale this as such, right? And one of the first bottlenecks or issues that we have is how you classify the different calligraphy types that you have from documents, right? Because at the moment we have trained basically models, as I said, for different types of calligraphy, and this is the best results that you can get is from this kind of model. So you need to first know what type of calligraphy you are looking at, and for that you need a specialist knowledge basically to do that classification. And so and it happens the same with the layouts that you are talking about, right? So you have many different types of layouts. Some of them might be running text, some of them might be formulaic, right? And some of them might be tables entirely, right? So this happens quite a lot with the documentation of the fleets of New Spain. You do have merchandise with prices, and so you need to identify different layouts, right? And so for that, the solution in reality is to, what we did in the case of the different calligraphy types was basically to create, and I didn't put it here because I thought, well, I'm going to run out of time if I show you absolutely everything. Yes, but we basically created also a calligraphy classifier. So, and that is to the level basically of renglón, not of page. So that basically means that we trained a model that you feed the documentation. So you feed basically thousands of documents to it, so the images as such, and it does the classification for you. So it tells you this has this percentage of itálica cursiva, this one of procesal encadenada, this is a combination, so you can know which route you are going to take with those documents, right? Because when we start to talk about thousands of documents, then we think, right, we cannot, as paleographers, to classify millions of documents into different types of layers, right? So with that, we needed to solve as well. And the same problem with the layouts, right? So we need to identify which documents have particular layouts and therefore routed to a specific model that allows you to do the layout and then the transcription. Does that make sense, Jorge?
Yes, perfectly. Thank you for your answer.
No problem.
Thanks.